This is number 9, the free response on the Chapter 11 Part 2 exam. This is the calculator one. And the first thing they're asking us to do is to write the third degree polynomial, giving us all the coefficients basically up at the top, and then to use that to approximate what's going on at 1.5. So that's when we'll need our calculator. So I'm looking here at this line to find all my coefficients. And this is centered around 2, so we want to make sure we have the x minus 2's. Get back up there. Okay. So the first coefficient is -3. That's for the x to the 0 term, so I'm not going to put anything there. Plus 5. This is the x to the 1 term, since that's the first derivative. X to the 1 over 1 factorial, if we want to put that. Plus 3. This is the second degree term. So our to the second and over 2 factorial. And then the third derivative is -8. So that's our polynomial. And then what they're expecting us to do then is to plug a 1.5 in. So we're going to say, I'm going to say something like f of 1.5 is approximately p of 1.5. And then I'm going to go to the calculator and plug those in. Okay, so we're going to have -3 plus 5 times 1.5 minus 2 plus 3 times 1.5 minus 2 squared. And I'm not going to do divided by 2 factorial since that's just 2. And then minus 8. And then 1.5 minus 2. That's cubed. And that's just 3 factorial. Remember, that's diamond divide, or you can, I guess maybe I'll show you. Diamond divide would give me the factorial there. All right, and I'm in auto, so I think it's going to give me the decimal, but if I have to hit the diamond enter, I can. So negative, back to here, oops, I better memorize that. -4.958. -4.958. Okay, and I think that's it on part A. Part B, use if the fourth derivative satisfies, so they specifically call out Lagrange error, and then this is going to be how they give me m. And then we're going to use that to explain why this thing can't be 5, although maybe it seems obvious because we already got a negative almost 5, which makes it feel like it's a typo, but it's not really. Okay, this is the free response on... Sorry, that other video was loading. Okay, so let's try again here. So error is less than or equal to, so this m is 3, and then x minus c. And we went to the third degree, so this is all going to be fourth, and the other way to tell it's a 4 is just the fact that they gave me the fourth derivative anyhow. Okay, so that's going to be what I'm going to calculate. So let's see here. So 3 times 1.5 minus 2 to the 4th divided by 4 factorial, so diamond divide. Okay, so 0.008, I'm just going to go with 0.008 here, 0.008. And then why this thing can't be equal to 5. So what I'm going to do is take that estimate that we got earlier, which was -4.958, and I believe that is correct. I think even on the test it seems like a wild, like why would they even ask at 5? -5 maybe would make more sense, but what I'm going to do is just going to go up and grab what I thought the estimate was, and then I'll add my error. So -4.951, let me write that down, -4.951, and then I'm going to do the same thing here, but I'm just going to subtract the error. So I'll subtract, okay, -4.966, -4.966. So I know my actual value is somewhere in between those two, which means negative or positive 5 is not even in the interval. I guess I should, instead of calling this actual, should call it f of 1.5. Has to fit in that interval. So I'm just going to say 5 does not fit within this interval. I think I took this directly from the AP exam, this particular problem, so it's not just me making a typo. I could double check that, but I'm pretty sure that's what happens. Okay, on C, they want us to write the fourth degree polynomial for this new function at about 0. In the past, I have actually built the table for this because that's just what makes the most sense to my, or did at the time make the most sense to my brain. But this time I'm not going to do that. Just know that if you would like me to, I will definitely show that to you. So what we really need to do is we need to look at this polynomial that we created earlier, and we're just going to substitute in an x squared plus 2. You'll sort of see what happens when we do that. So I'm just going to start, and I'm going to have to scroll up and down. I'm sorry about that. So negative 3 is the first term. So negative 3 plus 5. And then that was an x minus 2. So instead of an x, I'm going to write an x squared plus 2 because that's what's in here, and minus 2. So this was x minus 2. And this was the degree 1 term. And you can kind of maybe see what's going to happen, but I'll do it in a second. So then it was a 3 and then a minus 8. We'll see if we can remember that. So 3, and it was an x minus 2. So instead of an x, I'm putting that. This is this degree term. And then minus an 8, x minus 2 to the 3 over 3 factorial. And this, I'm going to go ahead and simplify this just so that you can tell that it's centered around 0 if you can't already. So the 2 and the minus 2 cancel, so this is just a 5x squared. And then a 3x to the 4th over 2 factorial. And then a minus 8x to the 6th over 3 factorial. Now what you have to know about this is, now this is the term that would have the 0th derivative, and this would actually be now the term that would have the second derivative for this function f, even though you know, I basically skipped over looking at the first derivative, but that's what's going to help us figure out the rest of this answer. So use this polynomial to explain why g must have a relative minimum. So the first thing we need to know is that for a min or max, the derivative has to be 0 or undefined. So that would be the first thing. So I'm going to say p prime of 0 is 0. So f prime of 0 is 0. And I'm going to write this even though you might not have to write this, meaning 0 is a candidate. I'm going to write over the top of that, or a max or min. Okay, so normally what we would want to do to decide if it was a minimum is we would want to do a number line analysis, but we can't really do that because we don't know what the function's doing on the left side and the right side of 2. We only know what's happening at 0, because that's where this function is made perfect. But we can use the second derivative test. So let's look at what p double prime of 0 would be. So p double prime of 0, and maybe we should just look at p prime of x first. There's a couple ways to find it. You could look here at that term, that second term, and kind of figure out, remember it was supposed to have a 2 factorial, so you kind of have to figure that in, but you can just take the second derivative. So the first derivative, I'm going to write it here just for some place to have it. So the first derivative, we get a 0, and then we get a 10x, and then we get like a 12x cubed over 2 factorial plus blah, blah, blah. The second derivative then is going to be 10 plus 24x over 2 factorial, da, da, da. And the reason I'm not too worried about the rest of that is because I'm plugging a 0 into the second derivative, which gives me a 10. So you can just go off of what you know about this, but I like to draw the picture. That means this thing is concave up. Now, this picture is not justification. I just draw the picture so that we can decide, well, we know that this thing is a max or a min. We know its shape now as far as concavity, so that means it has to be a minimum. So I would say since maybe this is our explanation. P prime of 0 equals 0, maybe I should call it F, and F double prime of 0, and maybe I should make that distinction that these are equal. F double prime of 0 equals P prime double prime of 0. Because F double prime of 0 is positive, there is a minimum